Alright, so we've seen that solving quadratic equations by completing the square can be a torturous process, not something you want to go through. So there's actually a shortcut we can use, and that's called the quadratic formula. So let's take a look at the quadratic formula, which looks daunting, but it's not. Before we do that, let's put this in standard form, because it's required to be in standard form in order to use the quadratic formula. Alright, so our values of A are 3, B is equal to -8, and C is equal to 4. Alright, and that's going to play a huge role in the quadratic formula. And this is the quadratic formula. It is x is equal to, meaning the roots when y is equal to 0, or the locations on the parabola in which the x-axis is intersected, thus the roots, will be equal to -b plus or minus the square root of b squared minus 4ac. All of that over 2 times a. Now, I'll explain where that comes from later. For now, let's just work it out. And we do know the roots from the previous video. So if you already have the notes in the previous video, you can check back and see we'll get the same result. Alright? So we're going to solve for the roots using the quadratic formula. X is equal to -8 plus or minus, meaning that you would actually do this equation twice, once where this is positive and once where this is negative. Alright? Plus or minus the square root of -8 squared, and parentheses are important. If you don't use parentheses when you make substitutions, you make mistakes. And your calculator, in this case, would make a different decision if you did not include them. Alright, times 3 times 4. Alright. All over 2 times 3. Alright, so let's just simplify this, and it should come out to be a pretty nice value. X is equal to -8 is +8, plus or minus the square root of -8 squared is 64, -4 times 3 is 12, times 4 would be 48. So it's going to be 64 minus 48. All of that divided by 2 times 3, which is 6. Alright, so I'm going to move down just for space. Alright, so we have x is equal to 8 plus or minus the square root of 16 over 6, which means x is equal to 8 plus or minus 4 over 6. So we have two possibilities. Either x is equal to 8 plus 4 over 6, or x is equal to 8 minus 4 over 6, which means x is equal to, that's 12 over 6, which is 2, and that's 4 over 6, which is 2/3. Okay? So those are the same two roots we got previously, so x is 2 and x is 2/3. Let's take a look at that again real fast. Alright, so we're going to factor completely. AC is 12. The product of A term and C term is 12. So factors that add up to be -8 are what we're looking for. So that would be -6 and -2 would be factors of 12 that add up to be -8. So that's 3x squared minus 6x minus 2x plus 4 equals 0. Alright, so we're factoring by grouping. The GCF of the first two terms and the second two terms is what we'll do. So that's going to be 3x, leaving over x minus 2. The GCF here is -2, leaving over x minus 2 equals 0. So our factors are 3x minus 2 and x minus 2 equals 0. And we get that either 3x minus 2 is equal to 0, which means x is equal to positive 2/3, which is what we got here. And the other case is x minus 2 equals 0, which means that x is equal to 2. So same answers. And the question again becomes, why use the quadratic formula when we can factor? And the answer is, factoring by grouping is harder. And in some cases you can't factor at all. And if you can't factor at all, you can complete the square, which is harder than using the quadratic formula. So the quadratic formula is the easiest method to use that works in all cases. So completing the square always works, and so does the quadratic formula, but the quadratic formula is easier. Alright, so let's take a look at why the quadratic formula works. So I'm going to erase everything. You can always go back and look at it again if you need to. So why does the quadratic formula work? Not that important to remember, but it's nice to know that things we do in mathematics aren't just a bunch of nonsense. Alright, so if we take a standard form quadratic equation and we complete the square, we'll see why. We'll see where the quadratic formula comes from. Because when you complete the square and solve for x, you get the value, you get the quadratic formula. So first thing we're going to do is divide everything by a. Alright, so we get x squared plus b over ax plus c over a is equal to 0. Alright, now we're going to complete this square, which we did the other day. Alright, so we have a square whose first quarter is x by x, whose second quarter has to total up to be b over ax, but they have to be split evenly. So this is going to be bx over 2a, and this is going to be bx over 2a, making those both half of this term, dividing this up evenly. So that makes this piece b over 2a. This piece is b over 2a as well. So it's going to be half of this term, and we're going to square it, so that'll be b squared over 4a squared. Alright? So this becomes x squared plus b over ax plus b over 2a, b over b squared over 4a squared minus b squared over 4a squared plus c over a. Alright, so what we've done is we've added a b squared over 4a squared, but we're not allowed to just add anything unless we compensate. So we're compensating for that by subtracting it as well. And now these three terms are equal to x plus b over 2a times x plus b over 2a, or x plus b over 2a squared minus b squared, equals 0, sorry, minus b squared over 4a squared plus c over a. Alright? So now there's only one x term, which is always the goal for solving the equation. So we're going to move these things to the other side. So we get x plus b over 2a squared is equal to b squared over 4a squared plus c over a. Oh, not plus. That's incorrect. It should be minus. By moving it to the other side, we have to subtract it from both sides. So it should become a negative, just like this became positive. Alright. You'll never do this again. It's just something you should see to understand where this formula comes from, and that it's not just something that's made up. Now we take now before we do anything, the formula only has one denominator, and it's going to be, so we're going to make this a common denominator. So that's going to be x plus b over 2a squared, which is equal to b squared over 4a squared minus, so to make this into a 4a squared, we'll make that a 4c, 4ac, by multiplying this by 4a and this by 4a. And since these now have a common denominator, we can write that as b squared minus 4ac over 4a squared. So this is where the contents of the radical came from. And now we take the square root of both sides to get rid of the square here. Alright, and that'll give us x, whoops, I picked black as a color, it doesn't show on a black screen. So that's x plus b over 2a is equal to plus and minus. When you take the square root of the non-x value, it becomes the positive and negative radicals, and some people ask why doesn't it do that over here. And to have 4 of them doesn't change anything. It's the same as having only 2, so it doesn't make a difference. So that'll be the square root of b squared minus 4ac, which does not have a square root, over the square root of 4a squared. Alright, so this radical actually goes all the way down. Okay, and now we will do a couple things at the same time just to get this over with. We'll move the negative b over 2a to the other side, plus or minus the square root of b squared minus 4ac, and the square root of 4a squared is actually also 2a. So that's pretty much the end of this. By putting these over their common denominator, we get the quadratic formula. Which we can use freely. Alright, so it'll solve for the roots regardless of what a, b, and c are. You might have radicals, so you might have to simplify those, but let's look at an interesting example now. Alright, so this is the formula. You can write it down, of course. Alright, let's erase that. Alright, so here's an example. I'm just making this up off the top of my head, so it's not supposed to have a good solution. So this is going to be 3x squared plus 10x plus, I don't know, 15. Not even, 30. Make it bigger. Alright, so a is equal to 3, b is equal to 10, c is equal to 30. So x is going to be equal to negative 10 plus or minus the square root of 10 squared minus 4 times 3 times 30, all of that over 2 times 3. So x is going to be equal to negative 10 plus or minus the square root of 100 minus, this is 12 times 30, 12 times 3 is 36, so that should be 360, all over 6. Alright, so let's finish this up, running out of time on the video. Plus and minus the square root of negative 260 over 6. Okay, moving on. X is equal to negative 10 plus or minus the square root of radical 260i. The negative comes out as an I, which we'll explain in the next video on imaginary numbers. So x is equal to negative 10 plus or minus the square root of the largest factor that goes into here would be, well, we'd simplify this radical, and these would be our answers if you finish simplifying this. I'm not going to now because we're running out of time, but you'll notice there's this negative radical, and that tells us that the parabola that we have here actually does not connect with the x-axis, so it doesn't have any roots. There are no roots. The I means that they are imaginary. So if we have a negative radical, our roots are imaginary, which we'll talk about in the next video on complex numbers.